Hello and good afternoon to all of you. I hope all of you are doing well and all of you are in good health. In today's class, we will discuss about memory and its management utilizing operating system. Now, before moving on with the memory management techniques, it is very much important for us to discuss some of the important fundamentals associated with computer's memory. As we all know, memory is a group of word or bytes, each with its own designate address value. This implies each and every cell in the computer's memory is assigned with a unique integer value known as the address value. These memory cells that are there in the computer system is used in order to host data temporarily or permanently during the course of execution. So the memory cells that are there in the computer system is used in order to host data permanently or temporarily during the course of execution. Now here, the data that we are talking about may be pertaining to two different aspects. The data may be pertaining to program instructions, or it may be pertaining to the data that the program instruction utilizes in order to perform operation. So here, the data that is permanently or temporarily stored in the computer's memory pertains to two different categories of information. One is the instruction set and the other one is the data set that the instruction utilizes in order to perform operation. Now it is the mandate of the computer architecture that the instruction and the data should be bought in the main memory during the course of execution. So whenever an instruction is to be executed by the processor, the instruction and the relevant data that the instruction makes use of to perform operation has to be brought to the main memory. So this is one of the mandate of the computer architecture, that any instruction that is to be executed and the data that is related to that particular instruction has to be brought to the main memory during the course of the instruction execution. Now this is performed with the help of a counter that is called as a program counter. So program counter keeps track of what is the instruction that is to be executed by the processor. Now here there is a problem. The problem is that the amount of main memory is very limited. So as we all know, main memory is of limited size, and in a computer system there might be many processors wanting to perform operation. That means many processors may be competing for allocation of memory in the main memory. So here the problem is that since the amount of main memory is very limited and many processors may be competing to have a space in the main memory, so what we need is we need a very efficient memory management technique. So there has to be a very efficient memory management technique that is capable of managing main memory amidst various processes that are there in the computer system. Now further, to increase the performance of a computer system, several processes are executed simultaneously, which calls for an effective management scheme. So this is another important aspect of a computer system. So in order to increase the system's throughput, that is performance, so several processes are executed simultaneously, which calls for an effective memory management scheme. So this is called as multi-programming. So in order to facilitate multi-programming, what we need to do is we need to have a memory management scheme that is capable of efficiently managing main memory amidst various processes that are there in the computer system. So these are some of the important fundamentals that are associated with computer's memory that needs to be kept in mind whenever a memory allocation or memory management technique is designed. Now let us talk something about memory management. Now memory management aims at optimal utilization of main memory. So as we have already learned about in the previous slide, memory management aims at optimal utilization of main memory. Now by optimal utilization of main memory, we try to refer to two different aspects. That is, firstly, by managing operations between main memory and the disk, because there has to be a mechanism in place that brings the processes that are to be executed from the secondary memory to the main memory during the course of the process execution. So this is one part of memory management, and the other one is dividing the space, that is the main memory, between the various processes during the course of execution. So here, whenever we talk about optimal utilization of main memory, we refer to two different aspects. First one is managing the operation between the main memory and the secondary storage devices, and then efficiently dividing the space between the processes that are there residing in the main memory during its course of execution. So these are the two important aspects optimization should be looked, or the perspective of optimization should be from. So one is the way how the exchange takes place between main memory and the disk, and subsequently the way how the division of the main memory takes place amidst the processes that are executing in the computer system. Memory management scheme handles or manages primary memory. So this is what we have learned. So memory management scheme handles or manages primary memory. It is responsible for movement of processes between main memory and disk during execution. So this is an important aspect. So memory management scheme handles or manages primary memory. So it is responsible for movement of processes between main memory and disk during execution, and subsequently the division of space between the various processes during the course of process execution. Memory management also keeps track of every memory location, allocated or free, and frequently updates the status, because as and when process is to be executed, the process has to be brought from the secondary memory to the main memory. So for bringing the process from the secondary memory to the main memory, the memory management scheme should keep track of every memory location, allocated or free, and frequent updation regarding this status is required so that it can execute a very efficient allocation mechanism. Memory management decides on the schedule of memory allocation. So the way how the memory allocation to the different processes that are there in the computer systems should be done. So it's also decided by the memory management scheme that we follow. So therefore, to achieve a degree of multiprogramming, proper utilization of memory and its effective memory management is very important. So this is what we have discussed in the previous slide as well. So in order to increase the throughput of a given computer system, or to improve the degree of multiprogramming, so proper utilization of memory and its effective memory management is very important. So memory management's objective is to efficiently manage migration of process between main memory and the secondary memory, and efficiently divide the memory space that is there amidst the various processes that are there in the computer system. So these are the two important objectives of memory management scheme. Now let us try and understand types of process address space that is there. So the way how we represent the address of the various processes. So we have three different types of addresses. We have symbolic address, we have relative address, and we have physical address. So for an example, the address that we use in the source code is called a symbolic address. So for an example, here I've taken an instance. I have declared an integer variable a. So here symbolic address for a would be ampersand a. So ampersand is the address operator. So ampersand along with the name of the variable will give me the address of the variable. But here ampersand a represents symbolic address, and a representation of address that is used in the source code whenever you're writing a program, because whenever you're working with a middle label or a high label language, you're not allowed to work with the physical address space. Then we have the relative address. So at the time of compilation, a compiler converts symbolic address into relative address. So whenever compilation of program is done, so compiler converts the symbolic address into relative address. That is, for an example, displacement of 100 byte from the base address of the code segment. So that is the way how relative address is. So with relation to something. So here it is done with relation to the base address of a given segment. So for an example, a byte that is stored at a displacement of 100 bytes from the base address of the code segment. So that is called as the relative address. So at the time of compilation, a compiler converts symbolic address into relative address. Then we have the physical address. So the loader generates the physical address at the time when the program is loaded into the main memory. So here, how do we generate the physical address? So we will be adding base address to the displacement. So if the base address is 1,000 and displacement is 100, so physical address is estimated as 1,000 plus 100, that is 10100. So this is the way how physical address is generated. So symbolic address represents the address that is used in the program code by the programmer in order to represent the address of a variable. Relative address is an address that is generated at compile time. So here what we do is we convert symbolic address into relative address, then eventually physical address. So the loader generates the physical address at the time when the program is loaded into the main memory. So how do we determine physical address? So it will be base address plus displacement. So if the base address is 1 quadruple 0 and the displacement is 1 double 0, so physical address is equated as 1 quadruple 0 plus 1 double 0, that is 1 0 1 double 0. So whenever, as I've already said, whenever programmer writes a programming code in mid-level or high-level programming platform, so it never sees the real physical address, or the programmer is not allowed to work with the physical address. So runtime mapping from virtual to physical address is performed by hardware device that is called as memory management unit. So memory management unit is a unit that is responsible for mapping the virtual address to the physical address in a given computer system. So these are the different types of process address space that may be there in a given computer system. Now, why is memory management required? So this is a very important question that everyone needs to seek answer for. So why do we need to have memory management mechanisms or schemes put in place in a given architecture? So the first one is optimal utilization of main memory. So as we all know, we have limited main memory, so which is to be utilized for storing processes as well as the data that is used by the processes in order to perform operation. So memory management scheme definitely helps in optimal utilization of main memory. It enables sharing of main memory space or the main memory between various processes. So the first reason why we require an efficient memory management scheme is that it facilitates optimal utilization of main memory. It enables sharing of main memory space between the various processes that are there in the computer system. Second one is to keep track of the used and the unused memory space, because the memory is being the utilization of memory is done in a real time. So constantly process migrate from the secondary memory to the main memory, and from the main memory to the secondary memory. So we need to keep track of which are the memory space that are being utilized and which are the memory space that are currently free, so that we can make optimal utilization of memory space. So to keep track of used and unused spaces in the computer's memory. Memory management scheme is used in order to perform abstraction, making process perceive a large to perceive as if a large amount of memory segment is allocated to it. Now actually what happens is that whenever processes request for main memory, now what we cannot do is we cannot bring the entire process into onto the main memory. So for an example, in some situation the size of the process may be bigger than the size of the main memory. So in order to make efficient utilization of main memory, what we do is we divide the processes into chunks. We divide the processes into pages, where at different point in time we will bring in different pages of the process to the main memory and execute that particular portion of code, and constant movement of pages pertaining to the processes is done in between secondary memory and the main memory. But for the user, it seems as if the entire process has been brought into the main memory and then the process is executed. So memory management scheme performs abstraction, making process perceive as if large amount of memory or large memory segment is allocated to it, but actually it does not happen. Now the fourth reason why do we need a memory management scheme is protects the memory allocation to each of the processes from being corrupted by another process. So this is also a very important point that we need to remember, that memory management scheme is capable of ensuring that no overlapping between processes happens in context of memory allocation. So no process is allowed to access the address space of some other process. So this is a very important aspect that memory management scheme looks upon. So it protects the memory allocation to each process from being corrupted by others. It helps to execute program larger than the size or amount of memory available. So this is what we have already talked about in the third point. So it allows a larger program to come into the main memory and execute, wherein the larger program is divided into pages and the relevant pages are brought into the main memory and it's executed. So constant migration of pages takes place between the main memory and the secondary memory that is pertaining to a particular process. So what does it enable? It enables a larger program to perform its execution. So it executes program larger than the size or amount of memory that is available by moving the program between primary memory and secondary memory using a swapping technique. So here what we do is we constantly swap the pages belonging to a process in and out of the main memory. Now, memory management scheme allocates and deallocates memory before and after process execution. So this is also a very important point. So it allocates memory to the various processes that are requesting for its execution, and it deallocates memory allocated to the processes after the execution of the process. So this is also an important action that memory management scheme performs. Next one is to minimize fragmentation related issues. So we'll come to fragmentation. But just remember that fragmentation basically refers to a situation where you create fragments, small fragments of the memory during the course of memory allocation to the processor. So memory management scheme should have or should help in minimizing fragmented related issues. And eventually, memory management scheme preserves data integrity while executing a process. So it's very much important. So whenever a process is performing its operation, so it has to perform operation in a manner that no other process is allowed to interrupt or interfere with the execution of that particular process. So this is what memory management scheme is capable of doing. So these are the reasons why do we need memory management scheme. First is for optimal utilization. Second one is to keep track of allocated and unused address space. Third one is to perform abstraction to make a process feel as if or perceive as if large amount of memory cell is allocated to it, where actually it does not so happen. It's supposed to give protection to the various processes by not allowing processes to encroach upon the address space of another process. It should allow execution of program that is larger than whatever is the size available. So here what do we do is we divide the program the entire process into pages, and only the relevant pages are brought into the main memory during the course of execution. So constant migration of pages takes place between the memory and the secondary memory. Memory management is responsible for allocation and deallocation of memory space before and after process execution. It should minimize fragmentation related issues, and eventually it should preserve data integrity while the process is executing or while the process is performing its operation. Now let us discuss some of the important memory management schemes. So memory management techniques are broadly classified into two categories. So the first category is called as continuous memory management scheme. Second one is called as non-continuous memory management scheme. So there are two types of memory management scheme. One is for continuous memory, so that's called as continuous memory management scheme. The other one is called as non-contiguous memory management scheme. In continuous memory management scheme or contiguous memory management scheme, we have single contiguous memory management scheme, and we have multiple partitioning, wherein case of non-contiguous memory management scheme we have paging and segmentation. Likewise, in case of multiple partitioning we have fixed partitioning and we have dynamic partitioning. So these are the memory management techniques that we'll be discussing in this unit. So we have two different types of memory management techniques. So contiguous memory management technique, non-contiguous memory management technique. Wherein contiguous memory management technique, we have single contiguous memory management scheme and partitioning. Where in case of multi-partitioning, we have fixed partitioning and dynamic partitioning, and in case of non-contiguous memory management scheme, we have paging and segmentation. So in today's class, what we have learned about is we have learned about some of the important memory fundamentals, right? Okay, then we have learned about what is memory management, right? We have learned about what are the objectives of memory management, and we have learned about what is performed when performed by the memory management schemes. Then we have learned about what are different types of address space, where we have learned about symbolic address, relative address, and physical address. And then we have learned about why is memory management scheme actually required, where we have talked about optimal utilization of memory space, we have talked about abstraction, we have talked about allocation and deallocation, we have talked about providing security to the processes, we have talked about facilitating execution of larger programs, we have talked about in brief fragmentation, and then we have talked about maintaining consistency. Eventually, we moved to various memory management schemes, where we have talked about different types of memory management schemes, where we have discussed contiguous and non-contiguous memory management scheme, and we have discussed its types. So in the upcoming classes, we'll be learning about the various memory management scheme in a greater detail. Till then, thank you and have a good day.